Okay, this is a problem. It says which of the triangles has the largest area, and they're isosceles, by the way. And it appears just looking at it that they have two sides of equal length, by the way. All right, let me just get my pen out again. So this, and this, all right? So this is good because I know it's basically, these two sides are always going to be the same, and what's happened at third side is, going from 1 to 5 to 10 to 15 to 19. All right, which one's the largest one? Now again, I always say that, visualizations are not bad, by the way, but my ability to visualize sometimes is very limited because my sense of scale might be off a little bit. So I'm going to put this one over here, and that would be the first one, which would be 10, 10, and 1. And looking at that, there's a height over here. All right, and that's not so bad. And the next one, kind of visualizing that, it's 10, 10, and then there's a 5. Now certainly I'm looking at this, it's still 10, and it's still a 10, but then this side over here is 5. Now certainly I know the area of a triangle is going to be 1/2 the base. The base is the bottom part times the height of it. So this one's out of the question. Now this one's the biggest one, all right? Now what's the next one going to be? Let's put this one down. The next one's going to be an equilateral triangle. It's still isosceles, by the way, all right? So I'm looking at this one, and the base of this one is even gotten bigger at this point, all right? So this one's out of the question, all right? Out of the question, by the way. Oh, by the way, this is 10, 10, 10. Let's make sure I'm writing those down in the order they gave me. 10, 10, 10, 10, 10, 5. And I'm not computing the area, by the way. I'm just saying it's bigger, all right? It's bigger. So whatever those areas are, it's getting bigger, all right? So the first one, relatively small. Second one got bigger. The third one is even bigger, by the way. And I'm not computing the area, by the way. Now again, the problem now is I go to the next one, and I got to look back over the sides, by the way. And the sides are going to be 10, 10, 15. All right, so this is where maybe my ability to visualize the height of it might start to collapse a little bit. All right, so what I want to do is talk about, is it a right triangle or not? All right, now if I thought about that, I'm going to say it's going to be something like this over here. And I'm wondering, if I have these two sides, 10 and 10, what would this side over be? It would be 200, right? I'm sorry, the root of 200. All right. Now the root of 200 is certainly less than 15. All right. So the 15 is longer. So what do I know about this guy over here? I know that this thing is going to start looking like this now. Again, it's an exaggeration over here. And that's going to be 15 over there. All right. Now this is the part where I'm starting to think about, what the height of it is. And I think about this, I only got the third one, and the third one is even going to get smaller than this one over here. So it'll be 10, and then this will be 10, and this is going to be 19, and the height's going to even be smaller. So really what I'm left off with, I'm left with two triangles now to look at, and the two triangles are going to be these two over here. I'll look at them. And I'm just going to get my eraser out. I got these two to look at. Get my eraser out. Get a big eraser in here. But basically boiled down to these two triangles now. All right, let me erase it. I don't need this anymore. All right, and what I'm going to do is use Heron's formula. All right, and Heron's formula is going to be like the semi-perimeter, which is A plus B plus C over 2. And the area is going to be the root of, it's going to be this semi-perimeter S, and then S minus A, S minus B, and S minus C. Now granted, I'm not really interested in computing the number. I'm interested in which one's larger. All right, so looking at this over here, I realize that A would be equal to, it's a root. And let me write this down over here. It's going to be A plus B plus C over 2 times, well, it's going to be A plus B plus C minus 2A. So it's going to be, let's see, A plus B plus C minus 2A over 2. I think you get the idea that there's a simple pattern to this over here. So I'm gonna just say, I think I know the pattern, but the twos have nothing to do with this, by the way, because they'll have two in it. So really I'm looking at, and by the way, the root has nothing to do with it either. It's gonna be P, which is A plus B plus C, the perimeter, all right? And then what are you gonna get? Let's take a look at that. You're gonna be P minus 2A, P minus 2B, and P minus 2C. That's what I'm looking at, all right? With the understanding that I have two things to look at, and I'm gonna say this is A, this is B, and this is C. This is A, this is B, and this is C, all right? What's the perimeter gonna be over here? Perimeter's 30. What's the perimeter over here? 10, 20, 35. Let's write it down now. What do you get over here? So the area of this one over here is going to be proportional to, all right? By the way, same constant of proportionality in both cases, by the way, so I'm not too worried about what that proportionality constant is. And I'm going to write it down for you, and this is going to be the 10, 10, 10, right? So the 10, 10, 10, that's easy to compute, I guess, right? So 30, and then you're going to get 30 minus 20, which is 10, 30 minus 20, which is 10, and then the 30 minus 20, which is 10. All right, that's not so bad. Let's do this one over here. I'll just call this A1, A2. Again, the proportionality constant is the same, by the way. It's because I'm a K value. I don't know what it is. I do know what it is, but it's not important to you. What do you get over here? 35. And then, let's see. It's going to be 35 minus 20, which is 15. 35 minus 20, which is 15. And then, let's see, the last one's going to be the perimeter minus twice the 15. That'd be 5. All right? Okay. I'm looking at this over here, and again, I'm looking at those numbers, by the way. I don't think I want to compute those numbers, but I'm looking at those two numbers, and I am going to conclude that, let's see, I'm going to look at them again. I'm a little tired right now, but I'm going to say this number here is bigger than that number over there. So I'm going to include the 10, 10, 15 is the largest one, which is going to be choice D. All right, choice D. And we're done. By the way, if you want to compute these numbers, you can. All right, they're really not that bad to compute. Maybe I should do that. So this number over here, kind of easy to compute. I'm going to say 30,000. And this number over here, a little more complicated to compute. But, let's see, 35 times 5, 150, and 25, 175. And then 15 times 15 is 225. Let me just go through that with you. 225, 175. Let's see, 5 times 5 is 25. I really don't have to do that. It's much larger. When I say much larger, it's certainly much larger than 30,000, by the way. All right, so D's the answer. Thank you.